Hello all, welcome to this online recording sessions in data science. So in this series of deep learning, so we are going to see the next concept, that is back propagation. Okay, so what is back propagation, why we need them, so how the steps involved in back propagations help the neurons to get trained and give us output. Okay, so all those things we'll be discussing in this session. Okay, so coming to what is back propagation. Okay, so where this step comes actually in the entire process of neural network implementation, entire flow of the neuron, so where this back propagation occurs. Okay, so and what are the steps that are involved. So I can draw a brief diagram, okay, to get it understand. So this is actual network, right? So from here the connection gets established between all the neurons. Okay, so from each and every neuron there will be a connection. Okay, so that the information will be passed on. Okay, it will be shared among the neurons and the output can be extracted. Okay, yeah, this is the actual. So these are x1, x2, x3 and so on up to xn. Okay, okay, so here when inputs are given, okay, it is passed on to hidden layer 1, then followed by hidden layer 2, then followed by output. Okay, yeah, okay, so here you will get a predicted output. Okay, see, if we are, this is the steps, right? So in between we'll had activation functions for hidden layers, as well as for input layers also we'll add activation function. For output layer also we'll add activation functions. Okay, to make the neurons fire. Okay, without activation function, the neuron will get not sufficient energy to get fire and to make the information to be passed on to the next neuron. Okay, yeah, so see, so from after this, so we'll get a predicted output, right? So here what we will do, we'll calculate the loss. Okay, so after getting the output, we'll compare this predicted output with the actual output with the help of loss function. Okay, there are many loss functions. Okay, for binary classification, for multi classification, okay, it varies. The loss functions will varies. Okay, binary cross entropy and all will come for multi classification, but mean square error, root mean square error will come for single. Okay, single general classification. Okay, yeah, so loss, with the help of loss function we will calculate actual value minus predicted value. Okay, so we'll see if the actual value and predicted value are varying too much, then what we need to do, we need to give this output as input again. Okay, okay, so in this process what will happen, this is actually the back propagation, right? So during this process there will be two steps happening. Okay, so one is chain rule and the other one is memmetization. Okay, these two steps occurs in back propagation. Okay, so, but to understand the back propagation steps, we need to consider this main steps. Okay, so what are those? One is forward pass. Forward pass is nothing but giving an input and getting an output. Okay, then backward pass is nothing but we use loss function and optimization technique to update the weights and modify them. Okay, so here we'll update the weights with the help of this loss function and optimization technique. Optimization techniques like SGD, okay, gradient descent, stochastic gradient descent, mini batch gradient descent. Okay, we will discuss each one detail in further sessions, what are optimizations, when we need to do optimization technique. So in each case what will happen, okay, if I use this optimization what will happen, if I use this optimization what will happen, all those things we will discuss in further sessions. So as of now you try to understand after calculating the loss function, that means actual value minus predicted value, we'll try to update the weights with the help of optimization technique. Okay, okay, so this will happen through back propagation. Okay, yeah, So if you look into the right side, so I have drawn one diagram, okay, my notes, okay. Here you can see what will happen actually, okay. Okay, so this I'll try to draw if possible separately, and I'll try to show you, okay. Okay, yeah, so here I can draw neatly. Yeah, so here the connections will take place, right? Yeah, now we need to see first notations, how we need to give notations, then we can study the back propagation steps using this only here itself, okay. This is y cap, okay. So this is x1. So how do you label inputs? So we label x11, this is x12, x13, and so on up to x1n, okay. So what is this, how do we indicate x values and w values, okay. We can see in this slide, okay. So we will use xii, okay. Xii means what? I means j means feature, okay. J means feature, I means index. So index and feature will be used in case of inputs, okay. While we are indicating inputs or features, it is in the type of xij. I means index, j means feature, okay. Next, fij. Fij is I means layer, j means index, okay. Here fij. Next, wij. So wij, how do you to the power of k? So wij, how do you indicate? So I is present layer or input, j is output. So k is layer. So to which layer it is coming, okay. So wij, okay. So here you can see I have written, so xij for inputs, fij for hidden layers, okay, wij for weights, okay, layer, current layer, okay. We need to remember this formula. So xij, we will use I for index, j for feature, fij, I for layer, j for index, okay. So now you come here and we need to give the notations here, okay. So how do we give? So this is w11, okay. So first let us label the index. So this is h11, this is layer 1, right, layer 2, hidden layer 1, okay, hidden layer 2. So h1, okay. So this one h1, hidden layer 1. So this is h2. So which cell it is in hidden layer only? This is first cell, right? So it will be h11. So here it will be second cell, right, h12. So here it will be third cell, right, h13. So here this is second layer, so that's why it will be h2, and the j value will be 1, 2, because this is first neuron, this is second neuron, okay. Yeah, so next this is f of 1, f of 1 comma 3, you can label like this, okay, since this is third layer, okay. This is first neuron, that's why it is 1, and j value is 3 because this is third layer, okay. Coming to weights, so it will be 1, 1, and it will be the to the power of 1, w1, 2. So see here, see input and see the output. Output is here 2, right? So it will be 2. So input is 1, right? So it will be 1, 2. So w1, 3. It is going to third neuron, so that's why it will be w13 to the power of 1. So similarly, you tell for this neuron how the notation will be there. So w2, 1. So from second input neuron, it is going to first hidden layer, okay. It will be w21 to the power of 1. So w2 to the power of 2, okay. w22 to the power of 1. So w23 to the power of 1. So again this will be w31 to the power of 1, w32 to the power of 1, w33 to the power of 1, okay. Similarly, for this x1 also you can calculate like this, okay. So now you tell me for this. So this is first, right, first neuron. So it will be w1, 1. So the power will be 2 because the weights are moving to second hidden layer. So the power will be 2. Okay, W1 2 to the power of 2. Okay, so for this also W21 to the power of 2, W22 to the power of 2, W31 to the power of 2, W32 to the power of 2. Okay, similarly W1 3, right, to the power of 3. So W1 W2, right, this is second, right, so 2, it is moving to third layer of output. Okay, it will be 2 3, power will be 3 because it is moving to third layer. So okay, in this way we will write all the weights. Okay, see, now you tell me, this is H11, right? So this is, what is H11 if I ask you whether it is input or output? So output for this neuron. Okay, for this input X11 will be coming, right, from here to here it will be coming. Okay, that means the output from X1, it is coming to H11. That means output is getting collected here. Now you see, you tell me for this, what will be the input? Input will be this cell, right? So again, what do I need to indicate? H11 or different one? So H1 only, right? So H11 only is output for this cell. H11 is only input for this. Okay, so separately I can write O11, this one as O12, O13, to in order to differentiate. Okay, this both are same, this one and this one are same, H13 and O13 are same, but H13 is the output, O13 is the input for next cell. Okay, this is output for the ones which we are getting input. Okay, so in this way we will, so here it will be O21, here it will be O22, so here it will be O13. Okay, yeah, so in this way we will write notations. Okay, with this now we are saying that with the help of optimization technique and loss function, these weights are getting modified. So due to the weights modification, there will be a change in the loss function. Okay, so actual value will be, predicted value will be minimized. Okay, so in this way loss functions, in this way back propagation works, right? So first we initialize the weight. Okay, if you note down the step-by-step procedure of calculating back propagation implementation part, first we will initialize the weight. Then for each xi, that means for each xi we will be passing xi forward through the network. Okay, so we will be passing xi to remaining cells. Okay, and getting output. So this is forward propagation. This is the very first step. Okay, in second only actual back propagation will be forward pass. Okay, after forward pass, what is the next scenario that will happen in back propagation? It will be backward pass. Okay, so here after getting the output from forward pass, we'll be calculating loss. Okay, so during this we will compute all the derivatives with the chain rule and memmetization. Okay, so after calculating the loss, so we'll add optimization, and then during this, with the help of chain rule and memmetization, the weights modification will takes place. Okay, we'll update the weights from end of the network to the start. Okay, we'll update the weights. Okay, all these weights will be modified. Okay, next step 3, what we'll do, we'll repeat the step 2 only. Okay, till new output will be equal to W new equal to W old. Okay, that means there will be less loss. Okay, yeah, this is the actual one. Okay, yeah, now let me calculate the weights separately. Okay, see, if I want to calculate a weight for this one, which one? This one, W11, right? W11 to the power of 3. Okay, this one, if I want to calculate this for this one, so W113. Okay, so how I am calculating? See, this is for W3, this is for W2. Okay, in third layer, how many weights we are getting? W11 to the power of 3. Okay, W21, So this is 2 and this is 1, right? 2 1 to the power of 3. Okay, we are having 3 in the third layer. Okay, in the second layer you see how many weights are there. How many weights are there? How many are there? We will see W 1 1, W 1 2, W W W 2 1, W 2 2 and W 3 1, W 3 2. Okay, everything to the power of 2. Okay, because this is second layer. Okay, so total if you calculate, so how many combinations will come if you ask? So here 4 cells, right? 4 into these are 3, so 4 into 3 12. Okay, here 3, right? Here 2, right? So 3 into 2 6 weights will get. Here 12 weights will get. So here 2 into 1, so 2 into 1 is nothing but 2, right? So total how many you counts? 12 plus 6, 18 plus 2, so total 20 weights we will get. So we will get 20 weights. Okay, in this particular diagram. So this 20 weights need to be updated every time. Okay, in order to reduce the loss. Okay, yeah. So in each layer we'll see how many weights will be coming. So in third layer we'll getting 2 weights. So the function will be like this. Okay, so this is the output, right? Okay, so f of 3 1. Okay, I have used h of 3 1, right? You can use f of 3 1 also for hidden layers. So it will be f of 2 1. So okay, so this is the output if you ask me. Okay, so from this output. So for calculating the loss, how do you do? So derivative of loss, okay, with respect to what? Derivative of what is the input here? What is the input? This is the input, right? For this output, derivative of O31. Okay, so this output where from how do we calculate derivative of O31 by what is the input for this? Okay, there are two inputs, O21, derivative of O21. Okay, this you can see here. Okay, this is the input for this O31. Okay, yeah. So derivative of O31, right? Yeah, derivative of O31 by derivative of O21. This is nothing but I can write like this also. Derivative of O loss with respect to derivative of O31 into derivative of O31. You see, denominator we am adding as a numerator, derivative of O31 by here see O21 is nothing but our W11. Okay, we will write derivative of W11. Okay, W11 to the power of 1. Okay, yeah. So now we got this. Okay, so in another way, this is the first equation that we will get. Then what is the other possibility? What is the other weight we are having? Derivative of loss with respect to derivative of O31. How do we get derivative of loss with respect to derivative of O31? So we are getting this one also. Okay, so derivative of O31 can be also calculated by considering the input of what? Derivative of W21. Okay, or O21. Okay, W21. Okay, so this is equation 2. Okay, yeah, I can see, you can see here. Okay, for this function we are taking 2. Next, coming to second layer. So in second layer you tell me how many will get equations. We'll get 6 equations. So we completed 2 equations, right? In this layer we get 2 equations. Here 6 equations. See, what are those equations? So derivative of loss with respect to derivative of W11 to the power of 2. Okay, so how do we get this? Okay, so how do we get this? How do we get this particular one? Okay, how do we get this particular one? Let me make you to understand clearly. Okay, yeah. So here if you see, I want to calculate this one, right? So here I expected how many? I expected 6 equations, right? 6 equations. So how we can calculate these 6 equations? Let me show you. Okay, so if you understand this, it will be easier for you for calculating all the equations. We'll getting n number of equations. If the network is very big, no, we'll get many equations. Okay, yeah. So for the calculating this, if you draw me like this, okay, so this is like this. Okay, yeah, actual diagram is like this. Okay, so this I want to calculate W11. Okay, so how I can calculate? So it is coming to here, from here it is coming to this 2, from here this 2, it is coming to here, right? So that's why I'm redrawing it here. Okay, this is W11 to the power of 2, and this is W12 to the power of 2. Okay, and this will be F11, this will be F21, this will be F22. Okay, and here it will be F31. Okay, so here we'll get loss function. Okay, y of y cap. Okay, this is loss function. Okay, so here we'll get 6 equations, right? Okay, what is the first equation? Derivative of loss with respect to W12. So 12, so 12 we will be calculating. Okay, how do we calculate 12? Sorry, 11. First we'll take 11, then we'll follow 12. Okay, so derivative of loss. So derivative of loss. Okay, with respect to derivative of, what is this? This is nothing but a O31, right? This is nothing but a O21. This is nothing but O22. Yeah, this is hidden layer, right? Okay, it can be written like this also. Okay, this is O11. Okay, so derivative of loss. What is the input? This is the input. So derivative of O31. So how do you get this O31? Derivative of O31. What is the input for this? Okay, this one, right? Derivative of O21. Okay, this is the input. So to calculate this derivative of O21, for derivative of O21, what is the input again? See, derivative of O11. This is nothing but a derivative of W11 to the power of 2. Okay, to the power of 11. Okay, to the power of 2. Okay, so that's why we get an equation like this. Okay, so similarly, now you tell me, so derivative of L with respect to derivative of W12. Okay, for this weight. Okay, how do we calculate in order to update this weight? Okay, so first from the last we need to come again till here. Okay, so derivative of loss with respect to derivative of O31. So derivative of O31 will be coming by taking the input of what? Derivative of O31. So I have completed O21, right? So now I can take O22, derivative of O22. Okay, so derivative of O22. So derivative of O22 will be coming from what? So derivative of O11. Okay, O11 here nothing but a derivative of W12. Okay, so that's why we get this equation, fourth equation. So this is third equation. Okay, similarly you calculate this in this similar way. You can calculate for remaining weights also. Okay, for this, taking this cell and redrawing it. Okay, so again last what we will do, we'll combine all this, we'll sum up all this. Okay, we'll sum up all this. Okay, so after summing up all this, what we will get? So we'll get like this. Okay, so this is for second layer, third layer or second layer, or 6 equations we will get. Okay, 4 5 6 7. Okay, 7, one more will also be coming. Okay, so now coming to here, first layer. Okay, so in first layer what will happen? So how many equations we'll get? So we'll get 12 equations. So okay, it will be somewhat you see, third layer is very small, second layer is somewhat complex, and first layer it will be again somewhat more complex, because many equations will be involving and many neurons will be coming. Okay, that's why we need to be cautious while we are calculating the updations of weights. Okay, so now here, so let me again erase this and again redraw it. Okay, redraw it for the first layer. Okay, so first layer, so how do we get and all we'll be seeing. Okay, so here we see. Okay, so you see this cell. Okay, so from this cell, if I see the connection, see, so here and for this cell and for this cell. Okay, from here. Okay, so again from here it is going to here. Okay, again till here. Okay, so from this cell it is going to here, it is going to here. Okay, okay, so from this cell it is going to here, it is so you highlight the one it is required here. Okay, W for first layer. Okay, so, and then calculate the weights. Okay, so derivative of loss with respect to derivative of W11, I need this. Okay, okay, so now how do I calculate this? So derivative of loss with respect to of derivative of O31. Okay, so derivative of O31 will be coming by what? Derivative of O21. So derivative of O21 will be coming from derivative of O11. Here you can see. So derivative of O11, derivative of O11 here, okay, will be coming through derivative of W11. Okay, yeah, see, this is what the other equation. Okay, so this is this will be 9th equation. Okay, yeah, so next will become, we have calculate the equation for W11. So similarly derivative of loss with respect to of derivative of W12. Okay, so how do we get this derivative of loss with respect to of derivative of O31? So derivative of O31 will be coming from derivative of O22. O22, right? Sorry, O21. First we complete O21. So O21, again we need to calculate. O11 we completed, right? So here it will be O12. So it will be derivative of O12. Okay, derivative of O12 will be coming from derivative of O12 will be coming from what? Derivative of W11. Okay, so you can see here. Okay, W12. Okay, okay, so you can see here. Here we can get it. Okay, so now what we will be doing? So we will be adding these two. Okay, so what is this actually? This equation, right? So what it is this actually? Okay, from O11. Okay, okay, so for this it will be a combination of these two. Okay, so we'll be adding these two equations. Okay, so similarly you'll be adding these two equations. Okay, for this you'll be adding this one and this one. Okay, if you see here, so for this neuron it is split off into f of x into g of x. Okay, so here what I am doing, I am adding f of x and g of x, right? So in order to get it. Okay, so in that way we calculate the this is what a chain rule. Why? Because it is plus, right? We are adding all the weights together. Okay, so this is what a chain rule. So we are adding everything. Okay, so how does the chain look? It looks like this, like it looks like this, addition of all the parameters of same component, right? Similarly we will be adding all those things. Okay, all those things. Okay, so that's why we are calling it as a chain rule. So this is the actual chain rule that is taking place here. Okay, so if you write all the equations, okay, if you write all the equations and see compare, okay, if you compare them, what will happen? If you compare them, we'll get the common derivatives. Okay, from all the equations we'll get some common features. Okay, so those common features we'll be separating out. Instead of calculating every time for every equation, we'll be separating them out and then we'll be using them. Okay, okay, so see, if you separate them, so if you see this is common. Okay, this equation is common. Okay, in here. Okay, here it is common, right? It is repeating again. Okay, so if you take common, what will happen? Derivative of O31 by derivative of O21 into derivative of O21 by derivative of O11 into derivative of O11 by derivative of W11 to the power of 1. Okay, so if I take common, so it will be derivative of derivative of O31 plus 1. Okay, so I'll be left with this, so that's why I'm taking here. So it will be 1, it will be like this. Okay, so it all takes time. In order to understand all this, you need to spend some time in order to understand all these equations, then only you'll be mastering in updating the equations. Okay, in order to study the equations and updating the weights. Okay, okay, so now that can be written also like this. Okay, here. Okay, this is what a memmetization. So memmetization is nothing but taking common parameters from all the equations and using it for remaining equations. Okay, so you do for some equations and you take those common values and use it for remaining equations. Okay, that is shortening of weights is called memmetization. Okay, so all together, if you ask me, we are using here memmetization and chain rule in order to update the weights. Okay, so now after this we'll be using optimization techniques. Okay, so this is what the back propagation algorithm working. Okay, so thank you all, thank you for giving this opportunity. So we'll be discussing next topic in further session. Okay, so thank you all.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.